Okay, this is the practice Newton force part 4. So for this question, I'm gonna go ahead and review what you've learned from part 3. As you can see that part 3, we have something very similar, but not exact. Okay, part 3, as you can see that we have the force that being pull an object at a certain angle. But for this one, you do not have a force. Actually, you have a force of tension, which is pulling an object up the incline, but not at a certain angle. So therefore, this question will be easier. So let me go ahead and read the question for you in order for you to figure out what I'm trying to say. Okay, a 63 kilograms water skier is pulled at a constant speed up a 14-degree incline by a rope parallel to the incline with a tension of 311. So basically what this telling you is that they're telling you what the mass is, they're telling you what the angle of the incline is, and also tell you what the force applied to the object. So let me go ahead and draw a free body diagram. So at this point, I'm just gonna go ahead and draw a certain thing. So a skier is being pulled up an incline at the angle. So let me go ahead and write out the angle since there's only one angle. So I'm gonna write down as angle. No angle 1 and angle 2. So an object is being pulled and the force of tension is parallel to the incline. Let me make sure that my force is actually parallel to the incline. And that would be forced. So let's go ahead and apply what we've learned. An object on incline, we have the force given to gravity. So basically, they tell you what the mass is, but you need to know what gravity is. In this case, gravity is always equal to 9.8 meters per second squared. That's what you need to know. And you also have to take into consideration with the angle. It's the same angle, that's why I'm not labeling as angle 1 and angle 2. So in my y direction, I'm gonna go ahead and identify as mg cosine. And there is a normal force which is perpendicular to the surface or perpendicular to the plane, which is equal to mg cosine theta. And let's look at the question to see if there is any coefficient that we imply, telling you that there is a friction. So the coefficient is not given. Now you test to determine what the angle is or what the mu is. So there is a friction. So let me go ahead and draw what the friction force would be in the opposite direction of the force applied. So this way. Oh, let me go ahead and write down the mass first, which is the weight that is pulling down when the force is trying to pull it up. And there is also another force, which is the frictional force right here. Fk. Let me go ahead and write out Fx. F is equal to mu k n in this case because the object is actually moving, so it is called kinetic, which therefore it means moving. So let's go ahead and derive what's in the y direction first. That's the first thing you do is equal to 0. And just like what I've said, the normal force is equal to the force due to the weight in this case right now. So the normal force has the magnitude, which is the same thing as mg cosine theta, for opposite directions. So therefore, I'm going to write a normal force, opposite direction of that force, equal to 0. Therefore, I could conclude that the normal force is equal to mg cosine theta because it is the opposite directions. They have to balance out in order for the object not to be moving or lifting, or to be lifted up in the y directions. So now I'm going to go ahead. Consider it equal ma But let's go ahead and look at what the question is telling you. So when you read the question, it says that at the constant speed, therefore there is no acceleration. So constant speed, constant velocity will do the same thing. So now I'm gonna go ahead and take 3 forces into consideration. So I have the force of the fly, and I have force of the friction, and I also have the force of the weight. So go ahead and stop. Writing it down. Minus Ff plus F is equal to 0. Okay, let's double check if those are the forces that actually act upon the object. Let's double check with the side first. Okay, look at over here. If the force is pointing to the left, I put negative side. Left, negative side. This is our convention. The vector is pointing to the left. It's negative. The vector pointing to the right is positive. Let's double check over there. Negative empty side. Yes, it's correct. Negative force of friction. Yes, it's correct. So now you're gonna have to go back to the easy equation right here. This is the force of friction is equal to the coefficient. In this case, it's kinetic mu k times normal force. You have figured out what normal force by derive this equation by using Newton's law of motion and set it equal to 0 because there's no acceleration. Therefore, you can conclude that the normal force is equal to the mg cosine. So let me go ahead and do one step by step. So basically, you carry whatever you have right there. You start writing it's the same because we're not doing anything with those variables, and then minus f. Ff is equal to mu kn. So I'm writing down mu kn plus f is equal to 0. So now you know what n is. So I'm gonna go ahead and say substitute n from here. So therefore I will have negative mg sine minus mu k. What my n is? My n is equal to mg cosine theta. So mg cosine theta plus f is equal to 0. For this one, you're going to have to figure out what mu k is. Let me go ahead and write this down right here. So this is when it gets complicated because you're going to have to do some moving variable. So for this one, I'm going to go ahead and add mu k, mg cosine theta, both sides. So that on the left hand side, I will get negative mg sine plus f is equal to mu k, mg cosine theta, right? And now I'm isolating everything. I'm trying to solve for mu k. So therefore, I'm going to put that as a mu k. So for this one, I'm trying to get rid of this one. So I'm trying to isolate this one. So what I will do is that I will divide both sides by that. Therefore, this one I will get only mu k. This is the one you're looking for. And on this side, I will have negative mg sine plus f divided by mg cosine. That's your final formula in order for you to figure out what the coefficient of kinetic thing is in this case. Okay, let's double check and look at what's actually happening into these two systems. One problem on the left, you are tasked to solve for the coefficient. With the one on the right, the coefficient is given. And then for the part B of this section, you're gonna have to do it by yourself. And in this case, since your tension is increasing, therefore there should be an acceleration. So you would just go ahead and apply sigma fx equal to ma. And from there, you replace what the theta is given into the equation and you solve for a.